What's up, everybody? What's up, MGTOW? So this video is going to be on metaphysics, and more specifically relating metaphysics to the operations of sound and how that kind of relates to quantum physics and also light or photon physics. Now, the reason why I'm making this video is basically to provide a counter argument to the more popular empiricist or strict materialist claims that are made about the universe. Because while empiricism is good and it's good to be able to measure things and relate things to other things and have relative sizes and measurements and units and things like that, the main empiricist claim, or the main strict materialist claim, is in essence solipsism in itself. And this philosophy of solipsism permeates throughout society, and you can see it especially with women and just in general in society. So the empiricists claim that only things that can be measured or weighed or verified by some type of sensory input in itself is false, because there are things that exist within the universe that are able to be measured by machine or some other type of instrument that cannot be perceived by the human senses without these extra sensory periphery machines, whatever you want to call it. And so this type of view leads to solipsism, because if you're making the claim that only that which I can measure or see or feel, touch, smell exists, that is in essence solipsism. Only things that exist because I view them, or because they exist within the realm of my perception. Now, there's numerous examples of why this is wrong. For example, before we had spectral analysis machines and all this other type of stuff, it would have been impossible to prove that high C existed. Because, for instance, a dog whistle, only a dog can hear a dog whistle. So to a person, it just looks like you're pretending to blow on a whistle. They can't hear the sound. And you can look at this chart here where it shows that humans can only really experience a small sliver of the sound that exists in the universe. And you can see in this chart here, similarly, that humans can only perceive a very limited bandwidth of light or radiation that exists within the universe. So again, the empiricists claim that only that which can be measured exists is verifiably false. And on top of that, I just think that it's extremely arrogant and maybe even a little bit naive to think that your generation or how you live now, they've solved all the problems to life, the universe, and everything. It just doesn't make any sense that, oh yeah, 2019, we've figured out everything. The entire universe, we know everything now. Now, secondly, a lot of empiricists will argue that you can't make up a transcendental realm. You can't make up a realm where the contradictions that exist in the dualistic reality we know as nature and life and the 3D world can be reconciled somehow. That there's a place where, there's a reconciliation of good and bad, left and right, up and down, things like that. But yet, modern scientists, have shown that the quantum field or the quantum realm, whatever you want to call it, defies these empiricist claims. Because within the quantum field, you have things that exist in multiple states at the same time, things that exist in multiple locations at the same time, things that can cancel each other out, and a few other properties, along with the fact that most, at least atheist scientists that study quantum physics, are basically telling you that the quantum particles are emanating from nowhere, that the base particles that make up our entire physical universe are coming from nowhere, that they're just kind of popping in and out of existence, and they're both in a wave state or a potential state and a particle state or a solid state at the same time at some times. And realistically, quantum physicians can barely explain this type of stuff. All they know is that there's something there, and within this field that does empirically exist, because there's no other way that they could see the quantum particles, the Higgs boson particle, and all that other stuff if it didn't exist. And what most popular scientists that study quantum physics, the best explanation that they can give is that these particles are coming from another dimension, another place that doesn't follow the same rules as our physical world. So therefore, there is a realm, some type of transcendent realm that our world emanates from, that follows a separate set of laws from the world that we live in, the 3D world, the world of time and space, basically. So again, the empiricists claim that there's no type of transcendent realm or extra dimensional qualities within or without of our world, outside of our world, is again verifiably false by science. And I find it interesting that a lot of people that claim empiricism or strict materialism don't really discuss quantum physics very much, because it kind of does shatter that whole worldview, where it's like kind of like science has gone so far into science that it's now coming back into metaphysics and coming back into claims that metaphysicians made thousands of years ago. All right, so I'm not going to give the typical transcendental argument, which basically in a nutshell is saying that things like math and logic and geometric shapes exist independently from the human mind. And while we might be able to perceive logic and perceive math and perceive geometry, these things exist independently from us. And we can see that in nature. You see a beehive has a hexagonal shape, and there's certain types of shapes on plant leaves like triangles, and there's cylinders and spheres and things like that exist in nature. We didn't create the idea of a circle. We didn't create the idea of a triangle. We didn't create the idea of a hexagon. We use those ideas. The same way, while we might give names to numbers, one will always be one, whether you call it one or uno or un or whatever you call it, one will always be one and will always be followed by two. Once you add another thing to one, it becomes two things. And once you add a third thing to it, becomes three things. No matter how you look at it, it's an objective fact in reality that numbers have a certain order, and it's always that way. And logic is the same thing. There's either valid logic or invalid logic. It's not like I can think one thing and it be valid logic, and you think the complete opposite thing and it also be valid. One of us is either wrong or both of us are wrong. But if we're thinking the opposite thing, only one of the logics is correct. And therefore, logic isn't something that's just made up by humans just to deal with life. We didn't just make it up. But it's something that's intangible. Math is intangible. Logic is intangible. So I'm going to go more into quantum mechanics, light, and sound, and look at some of the similarities between quantum mechanics, light, and sound, and specifically kind of looking at the wave-particle function, the Doppler effect, and cymatics. So if we look at both light and sound, we can see that light and sound have some properties that they share with each other. For instance, you can see here in these charts that both light and sound have the Doppler effect, which is basically depending on how far away you are from the source of either the light or sound, and the speed at which the light and the sound is moving will affect the way in which you perceive the light or sound. So the most classic example of this is when an ambulance is driving down the street, and when it's driving towards you, it has a higher pitch sound, and when it's driving away from you, it has a lower pitch sound, and when it's right in front of you, that's when you hear the actual pitch of the sound. And light has a similar effect, which is called redshift, and they use that to measure certain astronomical effects when they're looking at supposedly planets and other solar systems. They're not really looking at the planet. They're usually just looking at the main star and then measuring the wobble of the star and also measuring the redshift of the star to see how many planets could possibly be around it and the speed at which the star is moving. So we can see that light and sound have those similar properties. But also, if we look at a hologram and how a hologram works with a laser light and how it's created, and how sound is quote unquote created, we can see that there's some similarities there as well. So basically, when you look at what sound is something that's generated by a source, some type of kinetic energy, which is why what I said in a previous video, that all sound is percussive in a sense, because it requires an energy source to create a vibration, and then once you create that vibration, the sound goes into what we would call the sound envelope. And this is what creates the distinct properties of a sound. So if you look here at this synthesizer, you can see that it has a lot of components, but we're just going to focus on the oscillator and the sound envelope. So the oscillator is basically what generates the sound wave. There's different shapes of sound waves that you can use for your basic sound wave, which basically is mimicking something being struck or vibrated in a sense, some type of energy source. So in the sense of a computer, it's a digital source that's creating a digital vibration that goes through the oscillator, and it can create either a sine wave, which is kind of like a round dome shaped wave, a triangle or saw wave, which looks like saw teeth, and then a square wave, which is a square like shaped wave. And each of these waves has certain properties to it, like for instance, a sine wave or the round wave creates softer tones, and a square wave, which is square, creates lower tones better. I mean, you can change the pitch and octave of any of the tones, but for all intents and purposes, it's better to use a round wave for softer sound, and it's better to use a square wave for lower bassy sounds. And it's because of the sound envelope and also the room and all this other stuff, but we're not going to get into that right now. So once the sound comes from the source, and in this case of synthesizing sound, it's coming from the oscillator, then it goes into the sound envelope, which gives the sound its properties. So you have attack, which is how long after you press the button or strike the instrument or strike whatever that's making the sound, how long after that happens do you hear the sound? So for instance, a harp might have a lower or a higher attack because it takes longer after you pluck the string to hear the sound than a drum, which has a very short attack because as soon as you hit the drum skin, the sound, you hear the sound. Then you have decay, which is how long after the instrument has been struck does it take for the sound to decay or drop off. Then after that, you have reverb, after that you have sustain, which is basically how long after you strike the instrument does the source sound maintain or sustain its full power. So for instance, again, a drum, when you hit a drum skin, it has a very low sustain because the drum doesn't vibrate for very long, whereas a guitar string has a much longer sustain because when you strike the guitar string, it keeps vibrating on its own for quite a while. So lastly, you have release, and release is kind of similar to decay, except it's dependent on the time after you release from the key, because a synthesizer is based on either using a piano keyboard type thing or some type of button input. But the more interesting thing to note about the sound envelope and the use of the oscillator and the sound envelope is that pretty much any sound can be synthesized. Now, some sounds are much more difficult to synthesize than others, but just by using the sound envelope, you could create a sound differing from as much as a drum to a guitar sound, a piano sound to a horn sound, all basically just using the series of oscillator wave shapes and the sound envelope. And in fact, any song that you've heard that has synthesized piano, horns, violins, drums, bass, they're all formed using this same method of just the oscillator and sound envelope. So that's kind of the parameters of a sound. All sounds contain this envelope within them. And of course, room parameters like reverb and echo and other acoustic factors like the type of materials that exist in the room. Is it wood? Is it ceramic, glass, concrete, asphalt, things like that? How many people are in the room, the volume of space and the air density and all those type of things factor into a sound. But how the sound is produced is mainly through this process of kinetic energy source and sound envelope, which is dictated differently by the different type of instrument. Obviously, a drumstick only gives you one type of attack because you can only just hit the drum with the stick. There's no way to delay the sound or something like that, where as a violin you can kind of glide into a louder volume, so the attack might be lower because when you first start, plucking the string or bowing the string, then it could be quiet and then go to loud, or start off loud and go to quiet. So it's just something interesting to note about the sound envelope. So basically, when you hear a sound, what you're actually hearing is the collapse of a wave into a particle. Because if you look at this chart, when a sound is created, it creates a wave of potential. And when you hear the sound, when you, the observer, hear the sound, you're basically hearing only it in its particular form. The sound envelope that's being delivered to your ear is able to be received. Like, let's say, for instance, you're standing in an empty club. If you're standing to the left of the speakers or to the right of the speakers, in the back of the club, in the front of the club, you still hear the sound, but the sound is a wave throughout the entire club because everybody in the club can hear the same sound as you. So it's not a particle, it's a wave. And then the wave, quote unquote, collapses when you hear the sound and you receive the sound envelope to your ear, which creates the properties of the sound. Now, how this is similar to a hologram is because a hologram is very similar. Because if you cut a hologram into pieces, the entire image of the hologram is contained within each one of the pieces of the hologram, as you can see here in this chart. So again, it's very similar to sound, the way that light works in that sense, because you're just receiving an envelope or a particle of it, which you perceive to be the thing, but in actuality, there's a wave of potential for an entire room full of people to hear the same thing. So it's not like sound is a particle, and in fact, what you hear as a sound is really just a shadow or an echo of some type of kinetic energy being displaced in the universe. Okay, so another effect that sound shares with quantum mechanics is that of phasing. Now, when a particle is phased, basically they cancel each other out. Two particles that have the exact same properties cancel each other out. And the same thing happens with sound waves. Because, like, for instance, if you play two of the exact same record at the exact same time, basically just play one record on one turntable and another record on the other turntable, the mixer and everything is exactly equal. And when you play those two records with the same song, what will happen is it will cause a phase. And this is just a technical DJing term, but what happens is the sounds cancel each other out. And while you can still hear the sounds, you can hear this definite change in the way that the sound is played, and the way that the speakers fluctuate is almost the opposite of how they normally would pump the sound to vibrate the air to create the sound envelope. So basically, when you have two things that are exactly the same, they cancel each other out. And that happens both in quantum mechanics and in sound. So we can see that there are some definite similarities to sound, light, and quantum mechanics. And mainly the differences are the particles that they affect, or the hierarchy of particles that they affect, where sound is affecting regular, like, particles, atoms, and molecules and things like that in the air, where light is working on photons, and then quantum mechanics is working within the quantum realm with the tiny miniaturized particles that may or may not exist. But basically, the effect is the same. That there's the source that's generating what you experience is not the thing that you actually experience. Because, for instance, when you're listening to a drum sound, it's not that someone's hitting you on the head with a drumstick. You're experiencing an echo of the drum energy being released into the air, vibrating the air and the walls in the room and the people that are in the room. And then that sound envelope packet is being delivered to your ear, vibrating the hairs in your eardrum. And then your brain is interpreting that vibration as a note or a sound or a drum sound or metal hitting something or whatever the sound is that you hear. It's an echo of the thing. It's not the thing itself. And similarly, light is the same way. What we see as light is not what light is. Light is generated by a source, and then we see the light, and it's not like you can measure light. I mean, you can measure the speed of light, but it's not like you can capture light in a jar and weigh light. And then similarly, in the quantum realm, we see, quantum particles popping in and out of our reality, but where are they coming from? They must be coming from, if we follow this trend, they must be coming from some other source, some other transcendent realm that's creating our reality, and our reality is basically just an echo of this more transcendent, more real kind of dimension. But at the same time, we can't interact with this dimension on certain levels. And that's why probably when you get down to quantum mechanics like that, it just seems like a bunch of nonsense, new agey gobbledygook. But it's not. These are the highest level scientists in the world are working on the Higgs boson. It's like, that's where you go to work when you're the super mega genius. So for some reason, people leave these things out when talking about the arguments against metaphysics. All right, so my last proof here is going to be for cymatics. Now that we've kind of covered how sound works and what sound is and how it can reflect the quantum world as well, or the transcendent world, if you want to call it that. So now, if you look at these images, I'll also include some videos in the comment section or in the description so that you can see this in action, but I just don't want to get a copyright strike right now. But you can see that just from using certain frequencies or vibrational levels and just hitting basically what is sand on top of like a plate with certain frequencies of sound, that the sand on the plate arranges itself on its own into geometrical patterns. And not just like some simple geometrical patterns, but complex geometrical patterns. And also the fact that you can see that each frequency or pitch or tone or whatever causes a different geometrical pattern. And when you go from a lower vibration or lower hertz, whatever you want to call it, to higher pitch, higher hertz, higher vibration, the geometrical patterns get more complicated. Now, this isn't a magic trick. This isn't some type of party trick or something like that. This is actually how sound works and how wave fields affect reality. And this is just sound. This is just working on a particle, your basic atomic level. So if sound is doing this with just a very simple tone, that we can see that what our brain interprets as sound and what sound, quote unquote, looks like are two separate things. And that the fact that we can see that there is some deeper level of information contained within the sound wave. So you can see that there's different shapes and different complexities of geometric pattern that's formed by the sound wave simply by allowing the sound wave to resonate through this plate with sand on top of it. Now you can look at the sand as the material and the wave as the sound wave as what is emanating into the material, causing the sand, the material, to form into geometric shapes. So if geometric shapes are just something that's made up by humans, right, then how does a sound wave create a geometric shape? Is it possible that geometric shapes have some function and display that there is a higher order to basically three-dimensional life, and that there is actually a higher realm. I don't want to say higher realm, but a realm from which this realm emanates from. And that realm doesn't follow the same laws and basically could contain something that might appear to be contradictory within our 3D time-space type of realm. Now, I don't have an answer to this question because obviously it would be very difficult for us to look into another dimension, because obviously we can't do that because the limitations of us living in a 3D time and space type of thing. But just to finish this off, you can look at these Buddhist monk mandalas and you can notice that they're very similar to the shapes and geometric forms that are formed by using cymatics. So it's just an interesting question to ask, and it also definitely just, I don't want to say disproves, but it definitely puts, a really big red flag onto a strict empiricist or strict materialist worldview. And to claim that for a fact that there is no type of, transcendence or higher realm, to me, at least personally, seems a little bit foolish because you don't have conclusive evidence to prove it. And there's a lot of counter evidence against there being, only things that exist are things that I can measure. The only things that exist are things that are solid, that we can touch, taste, feel, smell, see. I mean, the highest level of scientists in the world are saying that's not true. But who am I to say? But then again, who are any of us to say? So I'll leave it at that. Everybody have a good day and go MGTOW.